Okay, let's answer this question. Find the equations of the tangent and normal to the curve. So we try to understand what normal is and what tangent and normal is and this curve. Now a tangent is a line, straight line that touches a circle as a curve without cutting it. It touches a curve but it doesn't cut the curve. Normal is a line that is perpendicular to this tangent. Okay, what is curve? Is the curve describing this quadratic function. Okay, so of course we know that we in a quadratic function ax squared plus bx plus c, we either have this kind of curve or this kind of curve depending on the value of a. If a is positive, we have this. So if a is greater than 0, it will have this form. If a is less than 0, if it's negative, it will be this form. Now a tangent is a line that touches this curve without cutting it. So when we say a line is normal to this curve, so it's let me use another line, another color. And normal is normal to this tangent. It touches it at an angle of 90 degrees. That's what it means. So we need to understand this now. Because of the simplicity of this function, y equals x squared minus 4, I can decide to find the zeros. So it's not part of this, but to make it mathematically beautiful and adorable. Okay, so we're going to be having this kind of situation. This is horizontal axis, and the vertical axis is y, and this is x. We're trying to know the nature of the curve we get. The nature is this. Well, let's see. Now we try to find if x is 0, if y is 0, what will x be? So here we have x squared minus 4 equals 0. Okay, if y is 0, so this is difference of squares. So x will give us -2 and +2. 2. Now this is 2 here, +2, maybe -2 here. So when x is 0, what is y? And so we go here again. If x is 0, 0 squared is 0, so x is -4. So somewhere here, maybe -4. Okay, and so we're having a curve that looks like this. See that? The nature of the curve we have. Now, this is y equals x squared minus 4. Now the question says we define equations of the tangent, two equations, one for the tangent, one for the normal, at when x is 3. This here is 3. So draw a straight line. Let me add something to this. Okay, draw a straight line until you meet this curve. So what will here be? So we are having a coordinate a. Let's call it a. X at this point is 3. What is y? We try and find out. Now, when x is 3, what is y from this equation? Y is 3 squared minus 4, which is 9 minus 4, which is 5. So here is +5. So the coordinate is x is 3, y is 5. Now, to find an equation, we just, along this, we at this point, we draw our tangent. You see that? A line that touches this circle without cutting it. So at this point, this is the coordinate. Now we choose an arbitrary point, say B, that has coordinate xy. Okay, that has coordinate xy. This is coordinate A. Having two coordinates, we can find the gradient. So let's call the gradient of this tangent m1 is x, because gradient is a gradient or slope is rise over run, which is vertical over horizontal, which is y minus y1 over x minus x1. So we call here x1 y1, we call here xy, and so that will give us y minus 5, x minus 3. Now at this point, because this curve and this tangent literally parallel, and so they have equal coefficient at this point, equal slope at this point. And so what is the slope of this curve, this function y equals x squared minus 4? The slope is dy dx. Okay, we differentiate, one of the applications of differentiation. So you differentiate this dy dx. Of course, this is changing y by changing s, so this is changing y by changing s. This and this mean the same. Okay, so this is something as this. So dy dx is 2x. Okay, then we find dy dx at the point where x equals 3. That will be 2 times 3, which is 6. And so this will be equated to 6. Okay, m1. The implication is that m1, let's go here, m1 equals 6. Okay, so we're having y minus 5 all over x minus 3 equals 6. You cross multiply, we're having y minus 5 equals 6 into x minus 3. We have y minus 5 equals 6s minus 18. So we're having y equals 6x minus 18 plus 5 is minus 13. Okay, you can, if you like, you could, this is correct, this okay. Or you can write it as y minus 6x plus 13 equals 0. This is the equation of the tangent to this curve. Now we look at, we found normal, a line normal to this. So normal means it will meet it at an angle of 90 degrees. Okay, so we choose an arbitrary point C that has, whose coordinate is xy. Again, we are considering C and A. Previously we considered A and B. And so that will be, we call it M2. M2 equals y minus 5 over x minus 3. But we don't know what M2 is. Now that is in coordinate geometry. If two lines meet at an angle of 90 degrees, the product of their slopes, M1 and M2, will be -1. So the slope we got, look at it, is 6. So what is M1? M1 is 6. So 6 M2 -1, 6 M2. Therefore M2 is -1 over 6. So this slope M2 is this. So we have y minus 5 all over x minus 3 equals -1 over 6. So I have y multiplying y minus 5 equals -1 multiplying x minus 3. I can have 6y minus 30 equals -1 plus 3. So I'm having 6y minus 33, because this is plus 3 crosses because negative, this is x, not okay. Minus 3 plus x equals 0. So I have 6y plus x minus 3 equals 0. This is the second equation, the equation of the line normal to the tangent. Thank you very much.